Okay, so in this video we're gonna have useful and useless grammar. We're gonna study about this thing. Useful grammar. A grammar is useful if two conditions fulfill. All the non-terminals are approachable from start state. All the non-terminals that are leaves end up at some terminal. Okay. Now, if you don't know what are terminals, go back and watch my previous videos. You'll get the concept of this. Otherwise, grammar is useless. Now, what is lemma? Lemma is a mathematical theorem which is used for a specific application. There are two lemmas, lemma 1 and lemma 2. In this particular video, we're going to study lemma 1. Okay, you have your grammar, and then you pass your grammar to this lemma, and this lemma filterizes your grammar, and according to the rules, whatever the rules are, it takes out unnecessary things and give you a refined form. Okay, ये filter का काम करता है. It's just like that, the air filter of your car. You're getting fresh air from the outside. Air is being filtered out, and some of the air is used into your AC air conditioner, and some by the engine breather pipe. Okay, it's just similar to that situation. Now, lemma is your set of rules. You have any language, you pass that language through a set of rules that's called lemma, and then you get a refined form. Okay, ब्लॉक कर देगा जो इसके रूल्स के मुताबिक नहीं होंगे. lemma blocks those rules or those situations which are not according to lemma's own constraint, and as an ultimate, as a refined product, comes out of this situation. Okay, so we have an example, we have an algorithm over here, example for lemma 1. Okay, begin old v. Old v is an empty set. New v, which is having a and a set a which is belonging to words, and words might also have spaces. While this is while old v is not equals to new v, while old variable is not, or while old v is not equals to new v, you'll understand this situation in a while. Hold on for a second. Just try to get the idea of what I'm trying to say over here. Begin the loop. Old v comes into your new v becomes old v. If while the situation, until and unless this situation becomes false, this thing is gonna keep happen. New v is gonna become old v, and new v, what is new v? Your old v union a, and a belongs to alpha, and alpha belongs to a set of old v. Okay, T union old v. Terminals, that set might be having terminals and old v. And my cell phone is getting a little bit heated up. It's not an issue. Okay, and the result, the loop ends, and the new v is saved into the result. Now look at here. Now what we'll do, we'll perform dry run. We have this column over here, we have new v, and then we have old v over here. Okay, your new v, we have this set over here. N is S, A, B, C, F, and terminals are B, C, and D. Okay, so S is a member of these would be a given set of rules. S is a member of A, B. S is a member of S can be replaced by A, C. B can be replaced by B, which is non-terminal leaf. C can be replaced by C, E, and D. E can be replaced by C, ED, E can be replaced by CD, which are terminals, and S can be replaced by BC. Now, what we are gonna do is we have our new V. Okay, so what is our new V? Forget about this for a while, about this alpha. Now, we'll start from here. Our empty set becomes old V. And what is new V? New V is a set of words, and words are your final leaves, and they might also have spaces. So according to this set, B and E, B and E. Over here, first we have our empty set. Empty set becomes old V. Empty set becomes old V. B and E becomes new V. How? Because we are having terminals in B and V. We can verify from this rule, whereas B is having a terminal and E is also having a terminal over here also. So that's why we have written B and E, and S is having a C is having a non-terminal and E is having a non-terminal. That is because we are having non-terminal sets that are leaves. Okay, non-terminals are pretty much your leaves. Okay, and then what we have is we have S, B, E, and C. So this old V while loop runs in, and this new V becomes old V. This new V becomes old V, and then again the situation checks in. S, B, E, and C. What is SB? How this S, B, E, and C comes in here? That is because our old set unionized with your set that is having your alpha, and alpha can be T union terminals union the old V. Now S, B, E, and C. S is having B. S is having B. S is having B, and A is not, can be considered as alpha over here. But since S is having B, that's why we are writing it in this set. Now, where did this B come from? B is having a terminal set, and it fulfills the situation. Non-terminal, and non-terminal is this old V, is in this old V set. Okay, E and C, where that E and C come from? E is from old V, and C, where is C? C is also having a value from old V. Now the thing is that there is an unnecessary A in this that can be considered alpha, and I've pretty much crossed out these two rules. That is because the lemma has filtered out these rules. Okay, if you look at that, if you look at the alpha, BCD union BE, where your BCD were your non-terminals and BE were your BE were your words that belongs to were from the set that belongs to words, and words belong to your words might also have spaces. And if we sort of unionize this thing, then we have B, C, D, B, and E. And out of all this situation, we are seeing that A is not used. So even though we are deriving this expression, this final expression, this sort of final expression, which is actually this BE unionized with S, B, and C, and E, F, S, and if you take a union, in union the same one cancels out and this situation comes in, so this is a filtered form. But we are looking at A is not involved over here, so any set involving A, now listen to me very carefully, any set involving A will be cancelled out and your lemma is filtered. And what was your grammar? Grammar is a set of these four members: nouns, terminals, and starting points in production, and this is passed into a lemma, and a refined form n bar comes in, and production rules are also altered, and your n is also altered. See, A is filtered out. A is filtered out, and only what is left? S, B, E, and C are left. S, B, C, and E are left. This is E, not F. Let me just get this thing down. So you see, A is being filtered out and a refined form comes in here. This is pretty much your lemma 1. And in the next video, we're going to learn about lemma 2.